table, but let's look at distributions of numbers, distributions of items within a population. Look at our data distributions. Let's look at test scores on the first test for business math. And let's say that our range goes from, let's say that nobody ever scores lower than 60 on the first test. And because I run out of room, let's say nobody ever scores better than 90. So let's take each score. Let's say we were grading tests, and our first test comes in at a 74. I'm going to put a dot above 74. Next test comes in at 83. Put a dot there. We had a 78. Put a dot there. 81. Another 78. A 76. Maybe an 86. Maybe a 68. 71, another 76, another 78, 77, another 76, another 77, an 80, another 78. So you can see as I build up these dots, it kind of takes shape. And as I build up these dots on the number line here, I get this kind of feel for what the data looks like. And I can actually draw a curve through the top of those dots if I fill them all in. And usually the curve will make a bell shape. You've probably all heard of the term bell curve or bell-shaped curve. And that's where this comes from. That curve is technically called a normal curve. The reason for that is, in nature, that is the shape that data normally takes. If I measured the height of people and put them on a number line like this with a dot plot, it would make a bell curve. If I had a well-done test, I put the scores on there, it would make a bell curve. Okay, so data normally takes that shape. Well, that curve can be described in with a couple of different attributes. So let's take my number line here. Let's say I plot my points and I get a bell curve shaped like this. Say I have another curve. That looks like this. How would I describe the difference between those two curves? Well, the red one's moved to the right. They're the same size, same width and stuff. The red one's moved higher. It has moved to larger numbers. Well, the easiest way for us to describe that is we describe the center. The center of the red curve is higher than the center of the blue curve. It's a larger number. The next thing we can do let's take this green curve here. Come on, you know you want to. There we go. We'll compare this green curve to the blue curve. Now they have the same center. The green and the blue curve are both at this location for their center, but the green curve is narrower than the blue curve. The blue curve is wider. The term we use for that is spread. Sometimes we use the term dispersion. How dispersed is the data? So we're going to talk about numerically describing the data rather than putting it in a table or in a picture for a graph. And we're talking about describing numerically the center and the spread. So let's talk about the center first of all. To do this, I'm going to create a list of numbers that we're going to use. I'm going to use 18, 7, 14, 26, and 15. There's my set of numbers. Measures the center. So again, that's the middle of that curve, wherever that location in the middle of that curve is. One of my measures of centers is the mean. The mean is what we've always known as the average. So notice the mean is found by taking, you add up the numbers. That little symbol that looks like kind of a funny shaped E is called the sum symbol. X represents each value. You add up the values and you divide by n. Remember, n is how many are in the set. So for this set here, we would add them all up. 18 plus 7 is 25, plus 14 is 34, plus 39, plus 26 is 65, plus 15 is 70, divided by 5 is 14. So the mean of that set of numbers is 14. We add them up and divide by how many are there. The next measure of center is called the median. The median is literally the middle of the data. To do the median, we have to do two steps. One, I put the data in order, smallest to largest. So let's do that first. Let's see, we've got 7, 14, 15, 18, and 26. So we put it in order from smallest to largest. Second step, find the position of the median. To do that, to find the position of the median, we're going to take 1/2 or 0.5 times n. What's n again? Well, in this set, it's the number of items in the set. It's 5 for this set. So 0.5 times 5 is 2.5. Now there's two possibilities here. This one is a decimal. If it's a decimal, we round up. So 2.5 would be rounded up to 3. The number in the third position is our median. So you got 1, 2, 3 right there. The 15 is our median. So the median of this data set is 15. You could just cross them off. Some of you have been taught to cross off the smallest and the largest, and work your way to the middle. For a small data set like this, that works. If we had like 85 data points in the set, that'd be a little tough to do. If you're doing this electronically in Excel, you can sort them to put them in order from smallest to largest. And then you can actually look at the side of the sheet and it'll tell you, how many rows you've used is how many items are there. It'll be nice to be able to find what position, just scroll to whatever row it is and pick it out. And that's why we're doing it this way. Now this was because n was 5, we got a decimal here, so we rounded it up. What if n were 6 or 8 or something else? So the other possibility, this is one possibility here, we get a decimal. The other possibility is, let's say, what if n is 8? So that position is going to be 0.5 times 8, which gives us what? 4. If this is an integer or a whole number, the median is between that and the next position. So this would be between the 4th and 5th number in the list. So let me give you a data set that has 8 numbers in it. I'm going to put them in order from smallest to largest as I make them up, just to make it easy. So let's say that this is 37, 42, 43, 45, 40. No, I'll do 45 twice right there. 45. I can, but I don't want to do it there for obvious reasons. It'll be obvious in a minute. 48, 52, and 60 are my numbers. So I just said my median is between the fourth and fifth numbers. So 1, 2, 3, 4, 5. There's my fourth and fifth number. How do I figure out what's between them? I average them together. Add them together and divide by 2 is 46.5. That's why I didn't want those both to be 45, because I wanted to be able to average them together.
If they were the same, then
it would just be 45. Yeah, if they were both 45, they're both the same. What's between them is just itself. So that is the median, the middle number. Again, like you said here, it wouldn't be too much work to just cross off the smallest and largest. Smallest and largest, smallest and largest. You end up with 2 numbers in the middle instead of 1. You're just going to average them together. The final measure of center, well, this book uses is something called the mode. The mode is the number that occurs most often. Now, in my first data set, there was no mode because there was no numbers that appeared more than once. In the data set that I have right here, the mode would be 48. That's the only number that appears twice in that data set. Depending on the textbook you're looking at, that's one thing with statistics is there's different fields of thought in statistics. Some textbooks will tell you there's one mode or there's no mode. If there isn't one single number that appears more than the rest, there is no mode. And that's the way we're going to look at it in this class. If there isn't a single number that appears more often than the rest, there is no mode. Some textbooks will say you can have up to 2 modes. So it can be, unimodal or bimodal are the technical terms. 1 mode or 2 modes. Some will say, well, it depends on how large the sample is. And they give you these weird formulas like square root of n minus 1 or whatever is how many modes you can have. Again, for this class, there's either 1 mode or there is no mode. Now there's another measure of center that we're going to talk about called the mid-range. The mid-range isn't discussed in your book, but it's one I have to mention. The mid-range is found by just taking the minimum, which is the smallest number, called the minimum, and the largest number, which is called the maximum, and we're just going to average those two together. Add them together and divide by 2. So for this last data set here, we have 37 is the smallest and 60 is the largest. So that'd be 37 plus 60 divided by 2. Now when you punch something like this in your calculator, I'm going to give you a word of warning. Do 37 plus 60, hit equals before you divide by 2. Because if you don't, order of operations takes over, it divides the 60 by 2 and then adds everything to it. So when you're doing the mean, always hit equals before you press divide. This is going to come out to be, what, 48.5, I believe? Okay. So that's our mid-range for that set of numbers. We've seen these 4 different measures of center, and really the first 3 are the most popular, mean, median, and mode. If we have a good set of data, we have that nice perfect bell curve, the mean, the median, and the mode will all be the same number. But most of our data is not nice and symmetrical and perfect like that. It's usually what we call skewed. So skewed, it might be stretched out in one direction. Like this here is what we call skewed left, because it's stretched out to the left. Here, the mean is going to be over here. The median, somewhere in here. And the mode is still going to be that highest point. So they're not going to be the same value. And the more skewed it is, the further apart those values are going to be. So that's one way to test to see if a data set is good. If it's symmetrical, a nice bell shape, is to find the mean, median, and mode and see if they're fairly close together. So that's skewed left, and of course we can have skewed right. That would be just the opposite. The mean's going to be over here. Median. And then the mode. So since there might be different, the question comes out, what's better, the mean, the median, or the mode for measuring the center of the data? What would you guys vote? The mode? Because it's easy? Well, the mode is always the highest point, but not necessarily the center. Okay, most people would say the mean, just because one, it's the first one we learned back in like 3rd grade. You average them together, right? And it feels good because we're doing this nice mathematical formula. You're crunching numbers and stuff. But let me give you an example. I'm going to give you a data set, and we're going to put them in order to make it easy on us. Let's do that. Let's find the mean. I'm going to add them together. 5 plus 9 is 14, plus 10 is 24, plus 12 is 36, plus 24 is 60. Over 5 gives us a mean of 12. The median, what number's in the middle here? 10. Okay. Don't need to do any intense calculation there. Now I'm going to add a number to this. And the number I'm going to add on the end of this is just 100. My mean is going to change. The mean, the total is now, what, 160 over 6, which is going to be 226.67 is now my mean. My median still changes, but my median is now between 10 and 11. Or 10 and 12, sorry. Yeah. I'll do my calculation before I finish talking. Between 10 and 12. 10 plus 12 divided by 2 is 11 is my median. You see here the mean went from 12 up to 26.67. The mean went from 10 up to 11. It didn't change much. The median will always be at the center. It's the middle. So this unusual value, this is called an extreme value here. Changed the mean a lot, but it didn't change the median very much. The median is what we call more resistant or more stable to those extreme values. Statistically speaking, the median is usually considered to be better, more reliable. Let me give you a great example as to where a case where that is the case.